In this video, we're going to look at some examples of volume. This is a little bit easier than surface area because you can imagine volume as I'm taking a shape, a prism, a pyramid, a sphere. I'm taking some shape and kind of how much water could that shape hold? How much volume is inside of that solid? So let's look at some examples here. For all of these, we're going to need our volume formulas. So really, there's just kind of three here. For pyramids and cones, these are both the same. I just do 1/3 of the base times the height. And here I used base with a capital B because this means the base of that pyramid or the base of the cone. So here I'm going to have to calculate the area of the base, whatever that shape is, and then just multiply it times 1/3 of the height. The same thing for a volume of any kind of prism. I would have to calculate base. Here I used a capital B, capital base, because here the base means the area of whatever shape that is on the bottom. Again, times the height. And for sphere, of course, gets its own formula. Kind of looks like area of a circle, almost pi r cubed is this one, and then times 4/3. So these will be the three that we're going to use here. Volume of a prism, sphere, pyramids and cones. That's what we're going to use. So the first one right off, here I have a prism. The base is sort of this kind of weird trapezoid shape. So I'm going to need to calculate the area of that base, again with a capital B, and then multiply it times the height. And then the height here would be 8 centimeters. All right, so the easiest way to do this is just to divide it into a rectangle and a triangle. I know that if I draw a line here, this has to be 6 tall. And then dividing the bottom, this would be 7, which would make this over here 7. So again, like with the previous problems, we have to be kind of observant about how we divide up our shapes and kind of how we calculate these numbers here. So the volume is really just going to be the base, which here is the rectangle and the triangle, times the height, which is 8. So the area of the rectangle is just 6 times 7, right? It's this times this side. And then if I add in the triangle, triangles are 1/2 times base times height. So here this would be 1/2 times 6 times 7. So getting a little complicated here, and then times the height, which is 8. All right, so this is the setup. Kind of the hardest step here is just making sure you have everything set up correctly to go through with the next step. All right, so 6 times 7 is 42. 1/2 times 6 times 7, that gives me 21. And I'm going to multiply that times the height, which again was 8. So let's add these together. 42 plus 21, that's going to give me 63. And I'll just bring down the 8 to bring down that height. We're going to multiply these together for our last step here. So 63 times 8 gives me 504. And our units here were centimeters. With volume, we end up with cubic centimeters. All right. So for perimeter would just be whatever the units are, centimeters. For area would be centimeters square. For volume, kind of imagine that we're getting a bunch of cubes inside of this shape, and we're trying to see how many cubes of water or air or whatever could I fit inside of this shape. All right. So a little bit more complicated here. What I want you to do here is pause the video and see if you can figure out this next one for number 5. Just with setting it up, I noticed that I have 2 hash marks. So if this is 6, this has to be 6. For the base of the prism is going to be this triangle, so I need to calculate the area of the triangle and then just multiply it times 8. So go ahead and pause the video here, see if you can figure that out on your own. Okay, so for number 5, again, what I wanted to do first is just calculate the area of the base. So here it was 1/2 times 6 times 6. The base again was a triangle. So I'm calculating the area of this base of the prism. And then the height, kind of how far it stretches back, was 8. All right, so 1/2 times 6 times 6, that gave me 18. And then times 8 was 144. Again, the units are cubed. So here this was cubic centimeters. For number 6, if you moved on to number 6, here again, I'm calculating the volume of the base, which here is a parallelogram, right? So I'm doing 8 times 6 to get that parallelogram. And I'm going to multiply it times the height, which was 7. So here I'm just doing really 6 times 8 times 7 is 336 cubic centimeters. Let's do kind of a more difficult one. So let's look at number 8, and you guys can tell I'm going to have you do number 7, but look at number 8. Here I've got a sphere. So I'm using that sphere formula. This is 4/3 times pi times the radius cubed. So here our radius is 6. So this could be times 6 cubed, which is 6 times 6 times 6. All right, and again, for pi, I always want to use 3.14 unless they tell me otherwise to get the same answer here. Okay, so first of all, I'm going to multiply 6 times 6 times 6, so 6 cubed. Bring this down 4/3 times pi, and then times 6 cubed, so this is times 216. And really, I'm just multiplying all these together. The easiest way to do this would be to multiply 216 times 4 and then divide that number by 3. So here I'm going to get 288 times pi. And this is what we're multiplying together. So I'm using 3.14 times 288. That's going to give me, let me draw this in, equals. It's going to give me 904 about 37. And again, with our units, this is going to be centimeters cubed, always cubic units for volume. All right, for number 9, again, I've got a prism here. The base is a circle, so I want to use my circular formula, and I'm just going to multiply it times 9. Now, it looks like it's kind of squished, it's kind of slanted, but due to Cavaliere's principle, this just says that I can always stack the same amount of number of coins inside of a stack, even if it's slanted or if it's straightened out, it's still going to be the same volume. So it doesn't matter that this is kind of tilted. I'm really just doing base times height again. The base here, I'm saying base with a capital B, just means the area of that bottom circle. All right, so we really need to do pi r squared to get that base, to get that circle. I'm doing pi times the radius is 5 squared, and we'll multiply that times the height, times 9. All right, 5 times 5 is 25, and then times 9 gives me 225 times pi. Again, when we multiply this, we want to use 3.14 for pi, and then multiply that together. I'm going to get a decimal here, 706.86, and then again, our units are going to be cubed, so this will be cubic centimeters. All right, for number 7, let me just kind of help you set this one up. For number 7, we have some missing information here, but just by being observant, I noticed that this is 4 centimeters, so this has to be 4 up here as well. The edge over here, I noticed that that's 5, that's 4, so this edge has to be 9. Down here, I noticed that this is 4. Let me kind of separate this into 2 rectangles. So down here, I noticed that this is 4, this is 8, and this would also have to be 4. So the best way to do this is really to use 2 bases. Use this rectangle here on the left, and then times that by this rectangle here on the right. Just kind of times those. Add these together, and then times that by the height, or by how far it stretches back, would be 10 centimeters. So again, I want you to pause the video here and see if you can solve that one on your own. All right, so what I did, again, I just used my base times height formula. So the base of this rectangle is 9 times 4. The base of this rectangle is 8 times 4. And if I just add those together, I got 36 and 32. If I add those together, I get 68 times the height was 10. So I'm doing 68 times 10 is 680, and this should be cubic centimeters. I don't know why I wrote it 2. Here we go. It should be cubic centimeters. All right, so moving on, here's number 11. And first, I'm going to have you pause the video here again. So go ahead, pause your video, take a look at number 10, and see if you can calculate the volume of this cylinder. All right, for this, Again, I'm using that base times height formula, base with a capital B, so not a lowercase b. Base with a capital B means find the area of this base shape, so find the area of this circle. All right, here we want to use pi r squared for the area of that circle, so we're doing pi times 3 squared times the height. The height is 8. So just kind of multiplying these together, 3 times 3 is 9, and then 9 times 8 is 72. So I'm doing 72 times 3.14 to get my answer here. 226.08 cubic centimeters. For number 11, though, it's a little bit trickier. Here you notice that you have kind of 1/4 or 1/4 of a cylinder. So I'm going to use my base times height formula, just like I did in number 10. But at the end, I'm going to multiply times 1/4, because here we just kind of have a section of that cylinder. All right, so the volume is going to be 1/4. The base is pi r squared again, so pi times 6 squared for that circle, this base right here. And again, it's just 1/4 of that circle. And then the height would be 10. How far does it stretch back? The height's going to be 10. So let's go ahead and multiply all these together. I'm going to just bring this down. So I'm doing 1/4 times pi. 6 times 6 is 36 times 10. All right, so we're just going to multiply all these together. 1/4 times 36 times 10, that gives me 90 pi. And again, just use 3.14 for pi. This is going to give us 282.6 cubic centimeters. All right, so again, kind of boring here, I know, but let's just kind of work through these examples. Try to do my best to be quick. I know it is very boring. Let's look at number 12, another difficult problem. So number 12, here I've got a cone. I'm going to use that cone formula, but I need to know what's the height. So my volume of a cone is 1/3 capital B for base times height. So the base here is just the circle. I'm going to use pi r squared for the circle, but the height I don't know. I know that the length is 13, but I sort of need to work backwards here and use the Pythagorean theorem. So to get the height, I'm really doing 5 squared, because I know that if this is 10, then the radius has to be 5. All right, so this squared plus the height squared is going to equal 13 squared. All right, so that's kind of my first step here, is just to use Pythagorean theorem. If I multiply these out, 5 times 5 is 25. Bring the rest down. H squared, it's going to equal 13 times 13 is 169. All right, so to figure out h squared, I'm just going to subtract 25 from both sides. So I get h squared is equal to 144. Excuse me. And then my last step here is just to square root that. So I'm going to get for the height is 12. Sorry about my sloppy handwriting here. There we go. My height is 12. All right, so all that work really just to plug that in over here. So the base, let's bring this down. The volume, let me kind of separate that. So the volume is going to be 1/3 times the base. Remember, the base here is just this circle. So I need to calculate the area of the circle. This is pi times the radius, 5 squared, and then times the height. So we figured out that the height was 12. All right, again, a lot of work on this one. Definitely a difficult problem. So let's kind of multiply this out. 5 times 5 is 25. Right, so I'm doing 1/3 times pi times 25 times 12. So definitely a lot of stuff here to multiply together. If I do 25 times 12 divided by 3, I just get 100. All right, and then bring down the pi. I always save the pi for last, so I'm doing 100 times 3.14. That's going to give me 314 cubic centimeters. All right, so there we go. Definitely a tricky problem there. Just be careful. It's very easy to just plug in 13 as your height, and that would completely throw off your problem here. Our height was actually 12. 13 would be the length. Okay, so let's try a really difficult one now. Here I have a cylinder, but it's hollow minus these two spheres. So I have to kind of figure out what's the volume of the cylinder and then subtract these two spheres. So the first thing I'm going to do is calculate the area of the base times the height. All right, so for the cylinder, I'm doing base times height. So the base is going to be pi r squared, pi times 9 squared, times the height, which is 26. All right, let's go ahead and multiply these together. So 9 times 9, oh, I'm sorry. There we go. Okay, so 9 times 9 is 81, and then times 26. I need to multiply these together, and I get 2,106 pi. All right, so remember, use 3.14 for pi, multiply these together, we're going to get 6612.84. All right, and this would be cubic centimeters. So this is kind of just the first step here. This is the volume of the cylinder, and now I need to figure out what's the area of these spheres and subtract these. All right, so for the spheres, we're going to use our volume formula. Let me change my color here for sphere. We're going to use the volume formula. So I'm doing volume is equal to 4/3 times pi times the radius here is 6, and that's 6 cubed. So definitely a lot of computation to do on this. There's also two spheres. They're both the same. So I'm just going to multiply whatever I get times 2. All right, let's go ahead and do the work here. So first of all, 2 times 4/3. If I multiply these fractions together, I get 8/3. I'll bring down the pi. And then 6 cubed, this is 6 times 6 times 6. This gives me 216. Okay, to multiply these together, what I want to do is 216 times 8 divided by 3. All right, so I'm going to get 576, and then just bring down the pi. So again, I did 216 times 8 divided by 3 to get 576. And then multiplying that times 3.14 is going to give me 1808.64. So again, definitely a long process with all these. They're all pretty difficult problems. Our last step here is just to subtract these. So this is the volume of the cylinder minus the two spheres. If I just subtract these, so I'm doing this minus this, my final answer should be 4,804, and let's just say 0.2. Let's just round to one decimal place here, and this would be cubic centimeters for your final answer. All right, so this is about as hard as it gets. I've got 2 more examples here that I want to go over, but this is definitely the hardest one I could come up with. I'm just subtracting these 2 volumes. All right, so let's look at number 14 here. I've got half of a sphere, so I'm going to let you guys do this one. But just notice that you have half of a sphere here. So you're using your sphere formula and then half of it. Okay, so the first thing you want to do is just put a half out here for half that sphere. And then our sphere formula is 4/3 times pi radius cubed. So the next thing that I did was 10 times 10 times 10 is 1,000. Multiplying these two fractions together, 1 times 4 is 4, 2 times 3 is 6. And when I multiply these together times 3.14, you should end up with this as your answer. All right, and again, for the last one, let's pause the video here. For the last one, number 15, just one hint here. I have 2 shapes. So I have a half of a sphere up here. I've got the half sphere, and then I also have the cylinder. I have a cylinder down here, so I'm going to have to do 2 different calculations and then add those together. So go ahead and pause the video here so you can get that on your own. All right, so for the half of a sphere, just like before, I did 1/2 times 4/3 pi r cubed, and that gave me 133.97. For the cylinder, this was base times height. Again, this is base with a capital B. I meant to write a capital here. There you go. Base with a capital B, which means find the area of this base of the, there we go, of the cylinder, base of the prism. So this is going to be pi r squared to get that. There we go, to get that circle. So pi times 4 squared, and then the height was 5. Let's go ahead and multiply these together. 4 squared was 16. 16 times 5 is 80. And then 80 times pi, that gave me 251.2. All right, so again, kind of a long process here. This is the, excuse me, this is the half the sphere. This is the cylinder. And if I just add these two together, it should give us our final answer here. So this should have been 385.17, and then this would be, again, cubic centimeters. All right, so that's about as difficult as I can make it. Really nothing too much more crazy than these. Hopefully that helps you out.